The future is what we hold on as we are thriving towards technologies in digitalizing the industry, and many upgrades have been made in various aspects. Thus, we can ensure that our product also can lead the way to as we justified. As you all know, the operation of twisting the doorknob is limited to those who are physically handicapped or to the people who lack control of their hands. Besides, elderly people also with arthritis, preventing them from using their hands, and people whose hands are loaded with objects. Not to mention, the hygiene in public is very important, as the possibility of the virus living on the surfaces which are frequently touched by so many people. Hands makes them a high risk of contamination, especially in times of pandemic such as the current COVID-19 outbreak. There are reported cases of the doorknobs causing virus spreading in apartments, hospitals, and other buildings. So, how to assist the handicapped elderly people in turning the doorknob and helping the public in creating a zero contact environment? Is it to install the automatic doors, because the automatic doors is very expensive, as we all know. Thus, our group come out with the solution that is invention of foot operated door openers that enables them to open the door with one step by foot. This invention can be easily installed and removed to the existing round doorknob for use primarily or portably by disabled person, elderly, or public people. To society, it can reduce the risk of contacting or spreading the virus via door handle and doorknobs, and could help them minimizing the coronavirus from spreading. So what are the objectives of this product? The objectives of this product is to design a solution for hands-free mechanisms that can replace the doorknob. And secondly is to produce a low-cost door opener which is reliable, workable, and also user-friendly.
So now come to functionality. We focus on 3S, which is solution, simple and safe. This product is a solution for hand-free door opener mechanism. This is the product and it is easy and simple to install. Just attach it on the doorknob and screw it for tighten up without destroying the surface of the door. 3M double tap is proposed to use to attach the stapler on the door. For safety consideration, the sharp edges are eliminated at the pedal. It is a simple door opener for easy turning of any round doorknob through use of the weight of the body. Here is the different view from attach the product on the door. The stimulation, let me introduce each component of the product. Here show the previous product before enhanced, and here show the product after enhanced. It has been enhanced from 12 components into 7 components. Besides, by using the nut and screw can make installation more easier and also minimize the installation process time. This product consists of 7 components. First, we have grip. Second, we have the stainless steel cable. And then we got the stapler holder. Next, we got the slider. And lastly, for the steel root, that to avoid the slider from leaving the holder.
And now we move on to engineering and ergonomic analysis for the product. For engineering analysis, we focus more on the stapler part. First, material selection. We need to do translation before we choose the suitable material for the stapler. We need to identify the function, constraint, objective, and free variable. The function of the stapler is need to act as a foot pedals, stepping base, and then for the constraint, we need it to be high stiffness and durable. For the objective, we need to minimize the cost and the mass, and then for free variables, the choices of materials and the choices of manufacturing process. After that, we use the CES software to find the most suitable materials based on the material index. After that, we rank all the suitable materials from the CAS software, and from the ranking, the highest rank is low alloy steel because of its low price and high stiffness. Second, finite element analysis or FEA. For this analysis, we use SolidWorks to analyze the stepper. We assume that 50 Newton force is applied on the stepper, and when the force is applied, the inner part of the stepper will get more stress. To reduce the stress, we need to use welding for the joining part. Then ergonomic analysis. We use CATIA software to do ergonomic analysis for our product. Based on the ruler analysis, the final score is 3 for our product that is moderate based on intermittent use. Our product can be used by using one leg. It may cause unstable position for the user bodies, but still can be controlled. And our product does not require so much energy to push down the stepper to open the doorknob, and then someone will not hurt their leg when operating this stepper.
Now I'm going to present the manufacturing process of the product. The first component is the grid clamp. The grid clamp will undergo 3D printing process to produce the component. Next is the slider. The slider will undergo laser cutting process which will cut the low alloy steel into the desired shape. Next, it will undergo drilling process so steel cable can attach slider to the grid clamp. Next, it will undergo welding process to attach the part of the low alloy steel. Lastly is the holder. The holder will undergo laser cutting process which will cut the low alloy steel into the desired shape, and it will make hole on the right side of it so steel rods can attach on the holder, as it will limit the slider to slide out. Lastly is the welding process. The welding process will attach the parts of the holder. The list of raw material that we will use to produce the product are low alloy steel, stainless steel, and EPS plastic.
For the product costing is accounting process to determining all business expenses during the creation of the product. So this is the total of the fixed cost, and this is the total variable cost. The total production cost is addition fixed cost and variable cost, and the price per unit is total production cost divided by the total unit produced, which is 400. Next, the assumption has made the profit margin is 40% from the cost per unit, and the selling price is cost per unit plus profit margin. For each one is 132 ringgit and 80 cents. For the return investment was calculated to measure the performance of company business, which we get 1.45%, and the break-even point is the sale that needed by company to cover the amount of fixed cost and the variable cost during the production time. This is 0.69 here, which is approximately to 1 year, to gain the profits from the production. For sustainability of the product is studied by using sustainability in CAD SolidWorks, as the steel alloy is set as the material for food operator door opener. In manufacturing process, the sheet material process is chosen as the manufacturing technology. So here is the result of sustainability. Lastly, the outcome of the sustainability of product, we can conclude the impact is decreased as the part has smaller volume. Hence, the best stepper is the part that has highest environmental impact. As we go through the product enhancements, the volume has decreased to minimize the impact of environmental. As a conclusion, the product focused on hygiene purpose. During pandemic COVID-19 situation, it could be useful for everyone in order to help handicapped person and elderly person. This quite simple mechanism. When a person step on the stepper, the cable will pull the doorknob bracket and twist it, and the door will open. So that's all for me. Thank you.